Okay, let's play digital detective for a bit. Welcome to this explainer, where we are going to dive into how some incredibly cutting-edge virtual simulations are being used to hack the global supply chain's most stubborn, frustrating bottlenecks.
The real delay in global trade actually happens long before a package ever hits your local delivery truck. To understand the sheer, massive scale of this problem, just look at this bustling maze at the Port of Montreal's Viau terminal. During peak season, this exact terminal handles up to 2,500 trucks in a single day. Everyday consumer goods are essentially trapped in what can often feel like the world's biggest traffic jam. It is a highly complex logistical puzzle where the sea meets the land, and frankly, the infrastructure is just stretched to its absolute limits. So the magic metric we're trying to shrink here is called truck turn time, or TTT. Basically, it's the total time a truck spends inside the terminal from the exact moment it enters the gate to the second it exits. And why does this matter so much? Because every single minute wasted here ripples out. We're talking major delays and inflated costs hitting our entire global economy. It's absolutely crucial, the ultimate benchmark for port efficiency, and right now, it is a glaring pain point.
Now, you might be thinking, well, just move the trucks faster, right? Actually, scratch that. It is way more complicated. This bottleneck isn't just about bad drivers or someone falling asleep at the wheel. It's a messy, chaotic cocktail of internal resource shortages and external chaos. Internally, terminal operators are battling insufficient gate lanes, super inefficient yard management, and a chronic lack of manpower. And externally, they're dealing with things totally out of their control. Imagine mega vessels suddenly dumping thousands of containers at once, uncoordinated data sharing across the whole supply chain, and unpredictable city traffic delaying arrivals.
It's like a giant puzzle, and you can trace exactly how interconnected these pain points are. For example, a single external factor, like a sudden seasonal peak in demand, immediately stresses those internal resources. That triggers indiscriminate container piling and a severe lack of yard equipment. You change one variable, like adding more trucks, and boom, it affects literally everything else down the line. It really proves that we absolutely cannot solve this crisis with simple guesswork. We need a much more sophisticated way to test our solutions. Because right now, the painful reality is that the baseline average wait time for a human-driven truck at this terminal is a staggering 88.2 minutes. I mean, just imagine sitting in a highly industrialized, noisy parking lot for almost an hour and a half just to drop off or pick up one single container. That is 88 minutes of idling engines, wasted fuel, and incredibly frustrated drivers who, by the way, are legally limited by their hours of service regulations. It is terribly inefficient, and man, is it expensive. To fix this, we need a way to test massive operational changes without, risking a real-world catastrophe. Enter Discrete Event Simulation, or DES. Researchers basically built a virtual clone of the port using this modeling tech. DES allows us to play God with operational variables. We can simulate the exact flow of trucks, the speed of the cranes, the processing time at the gates, all entirely in a risk-free virtual playgrounds that perfectly mimics the chaotic randomness of the real world. Now, what's really interesting here is the contrast between the hype and the reality. We usually picture autonomous trucks as these sleek, futuristic sci-fi concepts, like a driverless Volvo. But the technical reality actually comes down to the 6 SAE levels of driving automation. In our simulation, we aren't testing magical hovering cars. We are rigorously testing highly automated Level 4 and Level 5 vehicles. Vehicles that don't need driver brakes and can communicate seamlessly with the terminal software. And hey, this isn't just abstract theory either. Autonomous freight pilot projects are literally popping up everywhere, from Vancouver all the way to Ontario. The logistics industry is actively testing the waters for a robotic revolution. This technology is knocking on the terminal gates right now, which makes simulating their impact incredibly urgent for port authorities who are desperately trying to future-proof their operations. Okay, let's jump straight into our virtual laboratory and see how this builds across 4 gamified simulation scenarios. We want to see exactly what happens when we drop robots right into the traffic jam. Step 1 is our baseline of 88.2 minutes. Step 2 introduces a truck appointment system. Step 3 mixes in 35% autonomous vehicles into the regular fleet. And Step 4, well, that gives those autonomous vehicles dedicated VIP infrastructure. Let's look at the data.
So, in scenario 2, before we even touch the robots, simply implementing a truck appointment system provides a modest but very helpful victory. By forcing trucks to arrive in scheduled slots, rather than just showing up whenever they feel like it, we trim our average wait time down from 88.2 minutes to just over 78 minutes. It definitely smooths out the flow of traffic, but honestly, it's an administrative fix, not exactly a revolution. But wait, look at the dramatic drop in scenario 3. Introducing just a 35% mix of autonomous vehicles into the shared yard alongside human drivers slashes the overall average turn time to an incredibly satisfying 55.91 minutes. I mean, that is a massive efficiency leap. Just by replacing about a third of the fleet with automated trucks, the entire terminal breathes easier, and everyone, humans included, moves faster. So why does this leap happen so quickly? Well, as the researchers point out, it really comes down to hours of service limitations. Think about it. These robots don't get tired, they don't need mandated breaks, they don't stop for coffee, and because they are directly plugged into the central terminal operating system, they execute flawless, mathematically optimized routes through the yard without any human hesitation. They're basically the perfect, predictable employees. Naturally, looking at that, you'd think, let's give these highly efficient robots their very own dedicated VIP infrastructure in scenario 4. That should solve all our problems, right? The logic seems super sound. Give the autonomous trucks their own dedicated staging areas and partitioned yard cranes. Keep them entirely separate from the slower human drivers and let the fast robots go fast without humans getting in their way. But here is the incredible plot twist. Yes, the autonomous trucks become blazingly fast, dropping their individual turn time down to 32.86 minutes. But because the port's total resources are finite, partitioning off those cranes and lanes takes crucial resources away from the human drivers. As a result, the human trucks are punished severely, and their wait times drag right back up to over 70 minutes. The overall average of the entire system actually gets worse than when they all just shared the yard together. Which leaves us with a totally fascinating real-world dilemma as we try to optimize our supply chains. Are we truly prepared to navigate the messy trade-off of prioritizing algorithmic efficiency at the direct expense of human workers? This simulation absolutely proves that just throwing robots at a problem isn't a magic bullet if we don't consider the entire ecosystem. It's a powerful reminder that the future of logistics isn't just about writing better code. It's about how carefully we integrate that code with the human element. Thanks for joining me for this explainer. I'll leave you to ponder that exact question.